right, Thermochem notes number 3. We're going to go ahead and talk about the heat equation. Okay, so we're going to talk about this idea of specific heat capacity. Now, normally, if I hadn't been sick yesterday, we would have done a lab that really showed you guys what specific heat capacity looks like in real life. What we're going to do is we're going to lecture on it first, and then tomorrow's lab will sort of give you a good idea of what specific heat capacity is all about. So we will talk about specific heat capacity today on paper and define it and show how we use it in problems numerically. But then tomorrow we'll put more teeth to that. And in general, notes number 3, this is putting a quantitative face on a lot of things we've been talking about. So we've done a lot of qualitative stuff. We're like, hey, energy is exiting or energy is entering our system, that kind of thing. These notes are going to start helping us be like, specifically, X number of joules, so a specific number of joules are entering or exiting our system. So we're actually going to put numbers to things. So we're going back to math, although it's not super complicated math. The specific heat capacity of a substance, watch what I'm highlighting, is the amount of energy needed to change the temperature of 1 gram of something 1 degree Celsius. So the amount of energy needed to change the temperature of something 1 degree Celsius. 1 degree Celsius. So if you want to make the temperature of something go up by 1 degree, you only have 1 gram of it, that's its heat capacity, the charge. So this is basically how cheap or expensive it is to heat or cool something. So not all substances are created equal. Some substances heat up really easily. Some take forever to heat up. They're not created equal. They're not created equal. The units for heat capacity, by the way, are joules per grams degree Celsius. Or if you want that written out with the numerator on top, joules over grams degree Celsius. And I sort of think of this as the currency of heat. It's like a price. So if you guys go to the deli, for example, they'd be like, okay, salami is X number of dollars per pound, and cheddar cheese is X number of dollars per pound, and turkey's X number of dollars per pound, okay? So everything has a specific price. And in the same way, every substance has a specific heat price to heat it up or to change its temperature, and that's a specific heat capacity. And so I just sort of think of it as a cost. So it's like a price tag. It's basically like a price tag. That's how you should think of specific heat capacity. It's like a price tag. A price tag for changing in temperature or something. Let me go back for a second. Right there. Here you go. It'll also be recorded later as well. Well, I'm recording it right now. Crazy. This is so meta. Okay. Now, if I want to eat mac and cheese right now, let's pretend I'm in my kitchen. I got the pot of water right there. I just set it on the stove. I've got my box of mac and cheese. Am I going to be able to eat mac and cheese in the next 60 seconds? Well, no, of course not. Because it takes forever to heat up that water, doesn't it? It takes forever to heat up that water. Have you ever thought about why it takes so long for water to heat up and start boiling? No, I've never thought of it. Well, it's because of water's specific heat capacity. So that price to change the temperature of water. So the reason why it takes water forever to heat up is because of its specific heat capacity. Now here's the number you guys are going to have to memorize. This is sort of like a section 9 type situation on MSDS, or the density of water being 1.00 grams per milliliter. This is just one of those numbers that you just want to know. The specific heat capacity of liquid water, so not to confuse it with ice or anything, a liquid water is 4.18 joules per grams degree Celsius. 4.18, 4.18, 4.18. 4.18. 4.18, 4.18, 4.18. So you look me in the 4 when you .18. Oh man, I'm just feeling like such a 4. And then also it was 0.18, and I was like, holy 4.18, 4.18, 4.18, 4.18. Okay? Burn that into your brain. You'll need to use this. I will put it on your first worksheet when you're practicing, but you will need to have this burned upstairs eventually. So if I were to put this, you don't have to write this out, but here's a sentence form of what 4.18 means for water. The amount of energy that it takes to heat up just 1 gram of water, just 1 degree Celsius, is 4.18 joules. So if I just have a little tiny gram of water, so if I were to show you guys what that looks like, that's probably several grams of water. That's a small little amount on my desk. Like, you don't need a whole lot to have a gram. So let's pretend this is 1 gram on my desk. If I want to heat that up just 1 degree Celsius, I have to pump 4.18 joules of energy into it. If I want to cool that down 1 degree Celsius, I have to take out 4.18 joules to cool it down 1 degree Celsius. Water has a super high heat capacity. It's really high. So it's more than ice, iron, copper, gold, brick, cement, rocks, dry soil, wood. Like, water's got a really high heat capacity. It's part of the reason why it's the elixir of life. It's compared, like to compare it, it's got like a heat capacity like 5 times higher than like a rock, which sounds kind of backwards, but that's how it is. Anyways, let's talk about our new equation. So we used to have density equals mass over volume. That was like the equation we used a lot in Unit 2. The equation we're going to use a lot in Unit 3 is this guy. It is Q equals MC delta T. Q equals MC delta T, sometimes known as Q equals MCAT. If you're a real dork like Damon, you'll draw whiskers on this thing, put a little face, and little pointy ears, and like, oh, there's a cat right there, right? Looks pretty good, you guys. Mr. Pilcher, how do you have so many good jokes? Okay. All right, there you go. There are 4 variables here, okay? Q, M, C, and delta T. What is Q, Mr. Pilcher? Well, that stands for the quantity of heat, of energy. It should always be more than 0. See how I have a little more than 0 symbol? It will be in joules. Boom. Capital J. So if I ever have a problem like, all right, so Emerson has 27 joules of blah, blah, that's her Q for that problem. Okay? Harry removed 617 joules. That's his Q for the problem. What do you guys think M stands for? Mass. What do you think the units for mass are? Grams. Mass in grams. Alrighty, C, that's that new term. That is your specific heat capacity. And again, those units are joules per grams degrees Celsius. If I want to write that a slightly different way, joules over grams degrees Celsius. So some people kind of like having that joules in a true numerator up top. And delta T is a change in temperature. Okay, should be in degrees Celsius, of course. And please note that one should always be positive as well. So we're never going to use negatives for our Q and T. Those usually indicate when energy is leaving the system. What we're going to do is we're just going to simply use our words to indicate the negative. So we're going to say energy is removed or energy is added to the system. So we don't need to worry about negatives. Just always go for positives on these. And we'll use our words to indicate the direction, which is what that negative symbol usually does. So basically what's going to happen is there are 4 variables. I will give you 3 of them and simply ask you to solve for the 4th one. So if I give you Q, M, and C, you're solving for delta T, so on and so forth. So on and so forth. Let me give you guys a quick little service PSA, service announcement. You go ahead and put your pencil down. I don't want you taking notes on this. It's just a basic thing. Hey, so for sig figs, I'm not grading sig figs at all this unit. Okay, you can consider sig figs a thing of the past for now. They may come back like once or twice throughout the school year, but it won't be for a while. All right, and they're not at all this unit. So if Ryan gets the answer 42.435, For now on, let's just go with a couple decimals. Okay, so just call that 42.44. If she gives me 3 decimals, I'm not going to take off points. I just don't want to have to look at this hot mess here with like 10 decimals. Does that kind of make sense? Just give me a couple. Like these guys down here, 23.25, 0.25. Now, if your first couple after the decimal are zeros, please give me those first 2 sig figs after the decimal. So don't call this 0.00. I do want you to call that 0.036. And 3.0, let's call that 3.00. Does that kind of make sense? I'm not grading sig figs. That's generally just what I'm looking for. Are those 2 sig figs? Now, let's go ahead. We're going to get to this worksheet right here. Now, your quiz is not tomorrow. Normally, it would be tomorrow. It will be Monday is what we're looking at. Monday. Okay. So we're going to do some practice today, some practice tomorrow. So you guys are going to go ahead and get this worksheet. Now, problems 1, 2, and 3 are pretty related to the lab that we normally would have done yesterday, but we're now going to do tomorrow because I was sick, okay? So what I want you guys to do is when you get this worksheet, I want you to go ahead and we're going to focus on problem number 4 first. Now, we'll be using this equation, Q equals MC delta T, for all of these problems here. And I want to go ahead and just point out to you guys, here's a table of specific heat capacities. You will need this several times throughout this worksheet, okay? Throughout this worksheet. And it does have the infamous 4.18. I won't always provide that to you, but I'll give it to you for now. Let's go ahead and take a look at problem number 4 on this worksheet. So here's problem number 4. How much heat energy is required to warm 275 grams of water from 76 degrees Celsius to 87 degrees Celsius? Okay, well, we're going to find all the things that's provided between Q, M, C, and delta T, and we're going to solve for the one that's not provided. Okay, well, 275 grams, what is that? That's a mass, right? So I'll plug that in here, down there, 275 grams. All right, which one of these temperatures do I use for my T? The 76 or the 87? The difference, right? I want the difference between them. So I need to go ahead and find the difference between 87 and 76. Do I do 76 minus 87 or 87 minus 76? It doesn't matter. I just want the absolute value. Either way, you should get a delta T is equal to 11. So your delta T is going to be 11. Now, the problem here, it says how much heat energy. So which one of these variables is your heat energy? Well, no, that's your specific heat capacity. Q is your heat energy. So that's what we don't know. We're looking for Q. So I'm just going to rewrite Q down here because I don't know what it is. So that means I should have a C, but I don't see any other numbers here. So what is my C? Remember, this is water. So it's 4.18. And you forget, you can go back to the chart, specific heat capacities. Oh, this one's 4.18. Okay. All right. All right. So you plug in 4.18 right there. And this one's pretty straightforward when you're asked for the Q. Yes, ma'am?
So, like, on a test, if we had, like, other substance other than water, would you, like, put down, like, what their heat capacities are?
Right. So I will always provide you the specific heat capacities when you need them, except for water on a quiz or test. You should know that's 4.18 because this is going to make your life a lot easier because we're mostly going to work with water. Unless I'm asking you for the specific heat capacity, then you just solve for it. Does that kind of make sense? But I'll always provide them to you. This is the only specific heat capacity you have to memorize that is water is 4.18. Does that make sense? But anyways, this one ends up being pretty straightforward because you don't have to rearrange the equation at all. You just multiply those together. You'll find that your Q equals 12,644.5. And what are the units on that? Joules, right? Nice save. And I'm a model student, so of course I'm going to box that puppy up. Boom. Just like that. Maybe let's try one more of these. Let's take a look at number 5. Actually, you know what? Let's take a look at... Yeah, no, number 5 is good. Number 5 is good. A quantity of water is heated from 25 to 36.4 by absorbing 325 joules of heat energy. So we sent that much heat energy into it. What is the mass of the water? Okay, well, first of all, if it's water, what is that? What number do I know right away if it's water? 4.18 equals your C. All right, so I got my temperatures. What do I need to do with these guys? Find the difference. What is the difference between 36.4 and 25? And then 325, what is that? Is that your mass or is that your Q? That's your Q. And you are in fact looking for mass as it says in the problem. So I'm going to plug all these in. My Q is 325. I'll plug it in over here. I don't know what my M is, so I'm just going to rewrite the letter M. So I don't know what that is. That's what it's asking me for. My C is the 4.18. My delta T is the 11.4. So if I want to simplify this a little bit, 325 equals, I'm going to multiply my 4.18, my 11.4. So can someone tell me what 4.18 times 11.4 is? Yeah. So M times your 47.65. And I just took my 4.18 and my 11.4. I just multiply those together. Okay. So these two guys right here multiplied together, they make this guy. Now what do I have to do to both sides to get my M by itself? Divide by 47.65. And just remember, lots of times we'll be tempted to say, hey, subtract the 47.65. But remember, subtraction is the opposite of addition. So if this was plus 47.65, that would work. But division, division is the opposite of multiplication. So I need to go ahead and divide both sides here by my 47.65. It'll cancel out over here. Yeah, this is just standard algebra. So 325 divided by 47.65, that'll come out to be 6.82. And what are the units on that? Grams, because it's a mass, right? That equals your M. And of course, huh? No, that was just so I knew where I hit it on the board. You don't have to write that part. That's just for me to be able to find it because I cover them up with white ink before we do the problem. Okay, so you guys have the answer key on your desk or it's below this video if you guys are watching. I want you guys to get some good practice. And again, come quiz time, my expectation is that you can solve for Q, M, C, or delta T when I ask you, okay? So go ahead and get cooking.